In last video, we discussed about the introductory information about the gears. So in previous video, we discussed about the what are the types of the gears, why gears are used, gear types are used for power transmissions, and with some introduction, we move toward the terminology of the gear with different types of the gears, and we in last video we moved toward the terminology of this gear. So we discussed in last video about the terminology of that gear and different terms that are comes in this gear terminology, that are the pitch circles, addendum, dedendum. So what are the clearance, what is the circular pitch module, what are the diametral pitch, and we are also discussed about the relation between this module and diametral pitch. So we discussed in last video about this terminology. One more important term is remaining here as a pressure angle. So pressure angle, this pressure angle is nothing but this angle between the common normal, which is drawn at a point of contact of two meeting gears passing through the pitch point with the pitch line or the tangent to the two pitch circles at the pitch point. So it is the angle between two lines. One line is a common normal to the which is common normal, which is drawn at the pitch point, when that common normal is drawn through the pitch point, and when two gears are engaging. So these terms, what are the common normal and what is the common tangent at the pitch point. So as we move further, we go in detail with what is the common normal and what is the common tangent at the pitch point. First here we just imagine that two gears are engaging with each other. So when two gears are engaging with each other, there is a common point of contact. Between the two gears, between the two gear tools. And at that point of contact, if you draw a common normal, so that common normal and the angle between a line drawn, which is a tangent to the two pitch circles, which is also passing through this point of contact, So angle between these two lines is nothing but the pressure angle. So angle between the common normal and the common tangent, which are passing through the pitch point, when two gears are engaging with each other, which is nothing but a pressure angle. So this pressure angle, force transmitted along the normal, and that normal force have again two components. One is the along the common tangent and one is the perpendicular to the tangent. So pressure angle is the angle between the normal and the tangent, which is passing through the pitch point. And again, when these two gears are engaging, we transmit force along the normal. That normal again have two components. One is the along the tangent, and other is the perpendicularity. And force along the tangent or pitch line, which is also called the pitch line. Force along the tangent is responsible for the power transmission. It is a proportional to the cosine of angle of obliquity. So this pressure angle or angle of obliquity. So this cosine term of the angle of obliquity is related or proportional to the power transmission, and that force is along the pitch line. And another component or another force perpendicular to the pitch line, which produce thrust. Another force which is perpendicular to this pitch line or common tangent, which produce thrust, and which is also proportional to the sine of angle of obliquity or pressure angle, which is proportional to the sine of angle of sign of pressure angle or angle of obliquity. So to avoid larger thrust, it is always desirable that pressure angle should be smaller. To avoid larger thrust, it is always desirable to that pressure angle should be always small, so that the thrust will be smaller one. Thrust value will be smaller one. So the standard pressure angle are the 14.5 degree, and 20 degree. So standard pressure angles are the generally we observe like 14.5 degree and the 20 degree. So with this there are some terms. There are again some terms as a pressure line, or there are again some terms pressure line, which is a common normal, which is a pressure line, which is nothing but a common normal at the point of contact of the two meeting gears. Common normal at the point of contact of the two meeting gears, and that which is nothing but a from pitch point to the point of contact of the two gears. So this is line of the from the pitch point to the point of contact of the two gears. So again we move in next point. We discuss again these whatever these terms that we discussed here. So pressure line is the common normal at point of contact of the meeting gears is also known as a pressure line. Common normal at the point of contact also pressure line. Again there are some terms path of contact, again path of approach. So path of contact is a locus of points. Path of contact is a locus of points when two gears are engaging. At the start of engagement to the at the end of engagement, whatever that locus of point traced by during engagement of these two gears, which is nothing but a path of contact. And angle traced during this path of contact, is nothing but a that particular is known as the angle of action. So path of contact is the locus of point when two gears are engaging. At the end of engagement to the at the start of the engagement to the at the end of engagement, whatever the point of contact along these gear tools, that particular locus of points is nothing but a path of contact. And angle traced from start to the end of the engagement is nothing but the angle of action. So again this path of contact is divided into two parts: path of approach and path of recesses. So path of approach is nothing but the path of contact from beginning of the engagement of the pair, to the pitch point, and that angle traced during this path of approach is known as the angle of approach. And angle of recess, it is nothing but a path of contact from pitch point to the end of engagement. So this total path of contact I can separate out as a path of approach and path of recesses. So path of approach is nothing but the angle of contact from at the start of the engagement to the pitch point, and path of recesses is the from pitch point to the end of the engagement. So these are nothing but related to the pressure angles. So here we discuss different terms that are come under this gear terminology. Generally in this gear terminology we needed these pitch terms. Addendum, dedendum terms, their relations between the diametral pitch and the module, and this pressure angle and term related to this pressure angle that are needed generally needed in this gear terminology. So one more point. Now it is these are regarding this gear terminology. Now we shift toward the one more important point as a condition for constant velocity ratio of tooth reveal. Condition for constant velocity ratio of the tooth reveal. This is nothing but a law of gearing, which is also called as law of gearing. As soon as you come to the point of the tooth gears, this term is very essential, or this point is very essential, and it is a condition for the constant velocity ratio of the tooth reveal, or also it is called as a law of gearing. and so this is called as law of Field. So as we discussed in the drive, what is the velocity ratio? So velocity ratio is nothing but the ratio of angular velocity of the driven wheel to the angular velocity of the driver wheel. So that ratio is nothing but the velocity ratio. That whatever that terminology or whatever that approach we used in the belt drive topic, that same velocity ratio approach we used in the gear drive also. So in gear drive, that velocity ratio also we can say that angular velocity of the driven wheel to the angular velocity of the driver wheel. So velocity ratio, it is written in short form as a VR. VR is equal to omega 2 by omega 1. Omega 2 denote the angular velocity of driven wheel and omega 1 is the angular velocity of the driver wheel. So velocity ratio we can again discuss here, the same to the belt drive, same that we discussed in the belt drive. Now that ratio, that condition for the constant velocity ratio, omega 2 by omega 1, that particular ratio, condition for that particular ratio, that we discussed here, and which is also called as a log varying. So to discuss about this log varying, we first move towards this diagram. So this figure, this first part, represents the one tooth. This part represents the another tooth. So these are the we consider here as these two tooth are two curved bodies. These two tooth, these are the two tooths. The two tooths, these are engaged to each other. These curved bodies we consider here 1 and 2, and these curved bodies rotating at center O1 and center O2. These are rotating at center O1 and O2. First curved body rotated at center O1, second curved body rotated at center O2, and they are come in contact with point A1. So this curved body and this curved body come in contact with this point A1. So generally as point of contact is a single one, it is ideal case. Point of contact is a single one. Both curved bodies, this curved body, second curved body and first curved body come into contact at some point which is denoted here as A, which is a ideal case, but in actual practice there is some, this point of contact are different for this curved body and this curved body, and that are denoted here as A1 and A2. So in ideal case this A1 A2 are same, both points are same, but in actual practice this A1 and this A2 are somewhat different, very little different, A1 and A2. So here denoted this A1 is a point of contact at curved body 1, A2 is a point of contact at curved body 2. So these are the A1 A2 are the two coincident points on 1 and 2 respectively. So ideal case this A1 A2 are the coincident points. And RQ and MN now represent as a common tangent and common normal at the point of contact. So this RQ and MN are the common normal, are the common tangent and common normal, at the point of contact. So RQ and MN are this is the common tangent. To these two curved bodies. This is one curved body, this is another curved body. So common tangent to this curved body passing through point of contact, which is nothing but RQ, and common normal which is passing through point of contact is a MN. So that we discussed here, in this pressure angle term, angle between the common normal. Again we move further and we discussed about it. RQ is the common tangent passing through point of contact. MN is the common normal which is also passing through point of contact. And the point of contacts are the A1 A2. Point of contact are A1 A2, which are the coincident point. Now So that are written here. So omega 1, this curved body rotate with omega 1 angular velocity, this curved body rotate with angular velocity omega 2, omega 1 angular velocity omega 2 for the O2 second curved body respectively. Again, linear velocity at the point of contact represented by VA1 and VA2. Linear velocities, these are the linear velocities VA1 and VA2. Linear velocities VA1 and VA2, and that are perpendicular to the O1A1, that are perpendicular to this O1A1. So this O1A1 perpendicular to this O1A1, this is velocity, linear velocity component VA1 for the curved body 1, and for the curved body second, that velocity component, linear velocity component is VA2, which is perpendicular to this line O2A2. This is perpendicular to the line O2A2. So perpendicular to the line O2A2, this represents a linear velocity component for the curved body 2. That are written here, VA1 and VA2. Direction of these is the perpendicular to line joining O1 and A2. So this VA1 is perpendicular to O1A1, VA2 is perpendicular to O2A2. Now again we draw a line. O2M. We draw a line O2M perpendicular to this common normal. O2M passing through the center of this second rotating body, which is perpendicular to the common normal. Also O1N, which is also perpendicular to this common normal MN. Perpendicular to common normal MN, there is also O1N, which is also perpendicular. We prepare here two triangles. O2A2M and O1A1N. So these are the O2M are the perpendicular, O1N are the perpendicular. That we discussed here. O2M, O1N perpendicular to this common normal. So this is written here. Now when two bodies are in common contact, that components should be same one. So if you look at this VA1, so here VA1 cos alpha and VA2 cos beta, VA1 cos alpha. So for this VA1 cos alpha is nothing but this distance. From this point, VA1 cos alpha is nothing but this distance from this point to this point. This is the VA1 cos alpha, and VA2 cos beta, again this distance. So this distance is same. A2 to M, not M, A2 to this point, A2 to this point. So this distance we can write, if you consider this triangle A1, this point and this point. If you consider this triangle, small triangle, then we can write as VA1 cos alpha. If you consider this larger triangle, it will be written as VA2 cos beta. It is written as VA2 cos beta. And both are the same. Both values must be same because it represents this length from this point to this point. So these are must be same. And that are written here. VA1 cos alpha, VA2 cos beta. And this alpha is the angle between VA1 and the common normal. So alpha is the angle between this VA1 and the common normal. Beta is the angle between VA2 and the common normal. So that is written here. And then we can, for VA1, which is linear velocity, so we can write again V is equal to R omega. Now VA1 related to the omega 1, or related to first body, so angular velocity of first body is omega 1, and radius is nothing but O1A1. Radius for the first body is nothing but O1A1. So it becomes VA1, it becomes VA1 becomes omega 1 R omega. So O1A1 represents R, omega 1 represents this omega. Similarly for second body, and angular velocity for second body is omega 2, and radius for the second body is the O2A2. Radius for the second body is the O2A2. Radius is nothing but O2A2. That is written here. So these terms simplified like this. Now again we move further. So this term again we simplify here. Now for this cos alpha, for cos alpha again we write something. For cos alpha again we write something.